The periodic table is organized in such a way so that there is a pattern and reasoning for the placement of every single element on the table. The lines of the elements going vertically are called groups, and elements going horizontally are organized in periods. The first group of elements outlined in pink is called the alkali metals. The second group in yellow is called the alkaline earth metals. The next section is transition metals, which is outlined in green. The lanthanides and actinides are highlighted in striped pink and blue. Then you have other metals colored in green, metalloids, which are highlighted in orange, and nonmetals in dark purple, halogens in light purple, and finally noble gases in blue. To find information about a certain element on the table, first know the name of your element and locate it. For example, beryllium. Beryllium is located at period 2, group 2. Now you can see by looking at the box that the first thing you read is the number 4, symbolizing beryllium's atomic number 4. 4 is also the number of protons and electrons in an atom of the element beryllium. Next you see the letter Be, which is the element's symbol. Under Be you see the element's name, beryllium, and under that is the number 9.01, which is also the element's atomic mass. Each element contains a certain amount of protons, neutrons, and electrons located in its nucleus. The atomic number is always the same as the number of protons, and the number of protons is always the same as the number of electrons. To find out how many neutrons are in an element, subtract the atomic number, also the number of protons, from the atomic mass. In this case, we would subtract 4 from 9 to come to the conclusion that there are 5 neutrons in the atom. Here I drew what a beryllium atom would look like. We know based on the atomic number that there are 4 protons, and after subtracting the number of protons from the rounded atomic mass, we know that there are 5 neutrons. The neutrons and protons are all located in the nucleus of the atom. Surrounding the nucleus is an electron cloud where all the electrons in the atom are located. There are 4 electrons in the atom of beryllium. Finally, another type of diagram you can draw to represent the atom of an element is a Bohr diagram. A Bohr diagram has only electrons represented on it. To draw a Bohr diagram for the element beryllium, I started by drawing the element symbol. Around Be are shells where the electrons of the atom are located. The first shell can contain up to 2 electrons, and any shells after the first one can contain up to 8 electrons. For beryllium, the first 2 shells has 2 electrons, and the second shell has 2 more, totaling the 4 electrons in the atom. The very last shell is called a valence shell, and the electrons located on it are called valence electrons. And that's how you draw a Bohr diagram.